Okay, part two. Right, without doubt, probably the hardest question on the test. Explain the formation of an oxbow lake. Okay, now this is all about explaining how the meander develops over time. Now, normally in the exam, you might have the opportunity to draw a diagram, but because we've just drawn a diagram with the previous question, that wasn't an option with this one. So it's all about getting to the point quickly, not wasting too much space. It's only a 4-mark question, but getting those keywords to describe the sequence. In other words, what happens. And it's an explain question. Why? Because, due to, what happens next. So basically, it's all about, just first of all, in one short sentence, describing what's happening on the meander. We know the fastest flow of water is on the outside of the bend, and that's going to give us erosion. What happens next? How does it develop over time? So what happens? The outside of the bends move closer together as the meander neck becomes narrower, or the neck becomes tighter, it becomes closer together. Then again, what happens next in the story? You know, how does it develop over time? When we've got an event of high discharge, a storm event, something like that, the river is going to cut right across the neck and it's going to take a straight course. Deposition is then going to seal off the meander, leaving that classic horseshoe-shaped oxbow lake. Okay, you can kind of see it there. High storm event, the meander is going to be narrower, the river cuts across the neck, and you're going to get that deposition creating the oxbow lake. So it's all about describing the sequence, getting the keywords in, why does it happen, what happens next. Okay, fastest flow of the water on the outside of the bend causes erosion, the outside of the bends move together, the neck becomes narrower, and eventually in an area of high discharge, that neck is going to be eroded through. Okay, so make your notes. Right, okay, now this next one, when you first look at it, nice and easy, but very easy to drop marks. Okay, you can see there I've written meaning what. Okay, so for example, deforestation in Nepal, Tibet has increased the risk of flood. So that's a description. The question says explain why rivers flood. Now, again, what Abby has done fantastically well here is to take what's been said there and build on that. So in Bangladesh, the river floods as there are less plants to intercept the rainfall. That's the explanation. There's the description. Deforestation in Nepal has increased the floods. There's the explanation. Less plants to intercept rainfall. Floods can also occur on confluences, like in Tewkesbury, as there is a lot more water. Again, there's the description. Residents watch the river waters in their town rising where the river joins the River Severn. So what's happening? We've got a confluence, okay, especially after rainfall. Next one. Customers were evacuated from Meadowhall shopping centre as the river spit onto its floodplain. So what's caused the river to flood? We've got an increase in impermeable surfaces. Concrete used in towns mean the water can't infiltrate the soil, there's more surface runoff, and the river volume is increased, okay, because we're building on floodplains. That is the explanation. Okay, so you've got to take what's written there and build onto that an explanation using those keywords. It's more interception, we've got a confluence, therefore an increase in discharge. We've got concrete surfaces, meaning we've got less infiltration, okay? That's what you've got to do to get to the 3 marks. Okay, last question. A lot of you made hard work of this. Know what it says there, what I've underlined and circled. Choose either hard engineering or soft, not choose both, and explain why it is the better strategy. Okay, so what's really important with this, again, because note that keyword there, it's an explain why. In other words, give reasons. So for example, you've got to name probably at least 3 different strategies that we've talked about. So that could be dams, levees, straightening, spillways. Okay, if you're doing hard, if you're doing soft, it could have been do nothing, it could have been afforestation, it could have been floodplain zoning. Whatever you do, you must develop that answer. And I want you to see success. Remember that little mantra we have? See success later this year, social, economic, environmental. So for example, Abby said hard engineering is best. It can be expensive. Get that keyword in. Economic. Okay, for example, you must give an example. Building dams and creating reservoirs not only stops the risk of flooding, they allow water to be let out when needed. Use of drinking water and activities such as water skiing, fishing and bird watching. Social advantages, leisure. They provide plenty of different habitats, environmental benefits. Get those keywords in. Okay, so what you must do is give two examples, at least probably 3, 4 wouldn't be a disaster, and then develop it. How are you going to develop it? You're going to say, why is it good? And what you're going to do for that, you're going to say, why is it good for social, economic or environmental reasons? Okay, that is the crucial thing. So read through your answer, whether you've gone hard or soft, reread it now and think, right, how many examples have I given? And then think, how have I developed those answers by using those keywords, social, economic or environmental? Okay. Okay. Welcome to Mr. Norrington exam analysis on the foundation paper. Okay, now, first question, river channels are affected by different erosion processes. What you have to do here is to show that you've recognised them. Now, at first glance, this is TJ's one, and you can see there, in his excitement to do this, he's pretty much connected everything to everything. However, first little bit of tip there is keep it neat and tidy. But what TJ's done there that's very impressive is he's realised he's made a bit of a Horlicks of his diagram. So he's used numbers. So hydraulic action nicely matches with when the force of the water hits the bed and bank. Abrasion, you can see there, occurs when the load carried by the river hits the bed and banks. Attrition, as we know, when one bit of material knocks into another and it gets smaller. And of course, solution is when we've got the rocks dissolving. So look through yours, check through, make any corrections, and if for future, be clear. Okay, and a few of you made a bit of a dog's dinner of that one in terms of what it looked like. Okay, right. Show 3 characteristics. Okay, in other words, what does it look like? So we have meanders on there. We've got an oxbow lake. We've got a floodplain. TJ's got 3 marks straight away. You could also say things like it's flat. Okay, the river is getting wider. Those are other characteristics. Okay, so you're looking for basically saying what you can see there. Right, next one. Draw a label cross section to show how the inside of the bend of a meander is different from the outside of a meander. Now, you can see there what TJ's done. Very quickly, I'm just going to show you, this is Abby's one, and we can see over here, okay, these are the kind of things you need to get on. So let's start with the outside. It's faster than the inside, leading to more erosion. You can see that I've given an example. That gives the river cliff. You can see that it's deeper. Remember the question says, how is it different? So that it's deeper, it's faster flowing, and we've got the river cliff because of more erosion. Over on the inside, we've got no erosion, okay, because the speed of the river is slower, which means it's got less energy. So we've got deposition occurring on the inside, and that creates a slip-off slope. Okay, so carefully look through yours. Make sure you've got a diagram that looks something like that. Ignore that one on the right hand side, I've just crossed it out, but make sure you've got a cross section. Have you got your keywords? Have you got your processes, erosion, deposition, and is it fully labelled? Have you described? Okay, so look at yours, look at that, get your green pen going, and make the changes that you need to improve. Okay, now this next one, TJ's nailed this one. The fastest flow of the water is on the outside. This results in erosion because it's got more power. The outsides of the bends move closer together. The neck becomes narrow. There's a high discharge, usually after a flood or during a flood. The river cuts across the neck and takes a straight course. And of course, we know it's a horseshoe-shaped oxbow lake. So again, make any connections, get the green pen going if needed. Right. They're simple. This one, give one physical cause and one human. In other words, something natural, physical. So you can have ground saturated by days of heavy rainfall. Record wettest weather since June 1914. And we've got deforestation in Nepal, customers evacuated. So basically, physical is something natural. So we've got heavy rainfall, saturated ground, okay, records smashed by weather. Human, okay, deforestation, building on a floodplain, those kind of things. And I think pretty much everybody got those right. So just have a double check that you were on course with that one. Okay, because when snow melts, explain how snow melt can cause rivers to flood. Okay, when snow melts, it's going to leave an increase of water. Okay, and it's all going to melt at once, so you're going to get a rapid increase in the amount of water increase into the river. So that's going to cause the discharge to increase. Okay, and TJ summed that up brilliantly. When it's snow melt, it leaves behind water which will go to the river due to surface runoff. Good lad. Which will increase the river's discharge dramatically. Okay, and the reason he got 2 marks and not 3, okay, is because he needs to say something that it can all happen at once. It happens over a quick period of time. That's what he would have needed to get that 3rd mark. Okay, explain how flooding can be managed using hard engineering. Okay, now notice the key word there we've got is explain. Now, very quickly, this was the same question really on the higher and the foundation. Let's think carefully. Use examples. If you've gone for hard, say levees. Get your keywords in. What does it do? Then remember, you can see success. Social, economic, environmental, and then why? Because it's an explain question. Okay? So, for example, using dams to control the rivers at discharge, good, but then there's no explanation there. TJ's gone straight on to the next one. Levees to increase the height of the banks, that's good, that's what it does. Dredging increase the depth of the river, good. Reservoirs are made from freshwater lakes, spillway used to direct a flood away from certain areas. Those are fantastic descriptions. Why is it not getting higher marks than 3? Because it's not an explanation. You've got to then develop that. For example, if we're saying this one, for example, building dams and creating reservoirs not only stop the risk of flooding, they allow water to be let out when needed and are used for drinking water and activities such as water skiing, fishing and bird watching. They provide different habitats. Okay, it's really important. The only thing Abby's not done there, she's not used the keyword social, economic, environmental. Okay, but you need to explain how it can be managed. So levees increase the height of the banks. Okay, so what? That means the river can then hold more water and is less likely to flood. Dredging to increase the depth. Again, that's a description. What's the explanation? Again, this can double the amount of water held. The river can take more discharge and it's going to cause less flooding. Okay? We need to get those keywords in. Explain how it can be managed.